There are two prerequisites required to understand this clustering technique. First, we must know how to measure the distance between two data points, and then we have to define the term centroid. All right, let's start from distance. You can see two data points on a plane. Their coordinates are 3, 4.5, and 10, 2.5. The most intuitive way to measure the distance between them is by drawing a straight line from one to the other, right? That's also known as a Euclidean distance. The question is how to find that distance. The easiest way to do that is to create a right triangle. This side has a length of 10 minus 3, or 7. The other side has a length of 4.5 minus 2.5, or 2. Next, we can use the Pythagorean theorem and find the third side, right? It is the square root of 7 squared plus 2 squared. The result is 7.28. Therefore, the distance between the 2 points is 7.28 units. All right. Can we parameterize this? Say the coordinates of the 2 points are x1, y1, and x2, y2. In this case, the sides of the triangle are the absolute values of the differences between the x's and the y's. Then, following the Pythagorean, the Euclidean distance between the points is the square root of the sum of the square differences. That's also the Euclidean distance formula. While we are still here, let's generalize this notion to n-dimensional space. So, in two-dimensional space, the distance between 2 points, A and B, is the square root of the sum of the squares of the differences of the two coordinates for each point. Similarly, in three-dimensional space, we have the square root of the sum of the squares of the differences. But this time, we have all three coordinates. In n-dimensional space, we would have the same formula, but along each of the n axes. Cool! We need this concept for two reasons. First, when performing clustering, we would be finding the distance between clusters, right? Well, if we work in n-dimensional space, we must know how to measure the distance. And two, in the next section, this will be a central notion, so it makes sense to introduce it here. All right, let's finish off with the other concept, centroids. A centroid is the mean position of a group of points. In physics, this is known as the center of mass. So, for our 2 points, the centroid is the midpoint of the line which connects them. For 3 points, it would be somewhere between them, like shown in the graph. For 1,000 points, here it is. Cool. With this new knowledge, we can proceed to cluster analysis. Thanks for watching.